Nature is the most skilled of all designers. Numerous high-performance materials have been developed naturally over millions of years. Indeed, nature is an endless source of inspiration for researchers aiming to develop more efficient and sustainable biomaterials in their effort to replace fossil-based products. At Aalto University, Professor Markus Linder's group is studying the production of spiderweb using synthetic biology.
One of the strongest materials in nature that we know is spider silk. It's made of protein, and actually we have a hard time making materials which are as good as spider silk.
However, the production of a spiderweb by breeding spiders is impossible, as they are very territorial and aggressive. But now, scientists have succeeded in harnessing microbes to accomplish this important task through synthetic biology. Spiders produce silk in a manner that is very complex and difficult to replicate in the laboratory. The challenge is to first understand a particular biological system, and then rebuild it.
First thing we need to do is transfer the DNA information into another organism, like a bacteria, because they are easy to grow and they can actually make the proteins that we want. So they have the same machinery to be able to build the proteins, and we can scale the production of bacteria growing. So we can put them in a big tank, in a fermenter, and grow thousands of liters of them whenever we want. So we can't put the same exact DNA from the spider into the bacteria. We have to edit it. And we can make them different, actually in a good way. We can make them different so that they're much easier to make in an industrial setting.
Researchers are particularly fascinated by how molecules organize into these really strong materials. To understand the behavior of protein molecules, they use computational methods such as molecular dynamics simulation. Among other things, modeling helps to uncover what is most important in the process and to make predictions about what might work.
From the modeling, one can obtain ideas and what are really the things that matter. The primary unit in the spider silk-like proteins are amino acids in certain sequence.
For each position in the chain, you have 20 different amino acids to choose from. That means that if, for example, if we have silk proteins, that is about maybe 100 amino acids, so that is 20 to the exponent of 100, which is a very big number.
And this is actually the basis of how biological systems work.
And there's so much variation of what it really could be. But it actually could be a protein that's part of your brain, or it's part of something completely different than a silk protein. So the variation then that is possible from in this sequence is builds every protein we know, and all of nature is built from. So it's very versatile, this type of molecule.
Once a particular protein is developed, the next challenge is how to use it to produce an extremely fine fiber. Spiders utilize many complex processes that we can't directly copy.
Spiders have been evolved for hundreds of millions of years, so they have a really high mechanism of how they pull these fibers. What fascinates me is that I want to find out how we can do the same thing as they do.
Silk proteins consist of chains in which the main units of each chain are connected to each other when a thin thread is drawn from the protein solution. In Teemu Velisalmi's experiment, the silk solution produced by microbes forms a spiderweb-like thread. Pezmed Mohammadi, a researcher at the Center for Young Sin Bioscientists, has used an electric charge to shoot a biosynthetic spiderweb in thin strands. The spider silk produced by Pezmed has even undergone ballistic tests and has been able to demonstrate it is bulletproof. However, the commercial production of biosynthetic spiderweb still requires further research.
When we understand the process of how to design the proteins, how to produce them, what their interactions are, how they come together, then there's an unlimited possibilities of variations and combinations and so on. It will really build a platform for making materials in a new way.